Hey there, David from PowerProbe Tech, and you're probably looking at a strange looking silver aluminum case, wondering how to use it and what it is. This is the latest version of our demo board to show off some of the more advanced features of our circuit testing tools. You may already have and be familiar with the whiteboard demo board, which can show a lot of the features and can especially show off the ECT circuit tracer features. But this one's kind of new and kind of peculiar, so I'll kind of run you through how this particular one works. Alright, so you'll notice one side it's got all our circuitry and all the fancy stuff going on. The other side's pretty much blank. This is where you'll be able to display the PowerProbe tools. There's already Velcro strips on this one. Yours may or may not have them already. You can put them on depending on where you want to position the tools that you have. Alright. Let's keep going. And you'll notice there may be one loose part. This relay is for the relay activated fan circuit, which normally has to be taken out for you to close the case. There's just not room in there for it. And let's look over here. Now you'll see there's a power cable for the demo board. Now this needs to be connected to a 12 volt power source, preferably with enough amps to be able to trip the circuit breaker. So the limit of the tool is like 20-25 amps minimum. So the easiest solution is a battery, an automotive battery. That'll run all day long. We do use many times our PowerProbe jumper pack with just a set of straight cables on it, and we'll connect those to this. Those will run for a few hours. Be aware though, if you use our jumper pack, you cannot use the jumper cables that come with the jumper pack. This protection circuit will prevent it from working. So you have to find either a non-protected or just a fused connector set to connect to these jumper packs to power up the board. Also be aware, only connect to a 12 volt power supply. Although the tools can handle up to 24 volt, the display board has some electronics that can't handle more than 12, so please only connect to 12 volt power supply. Now the demo board can be displayed two ways, either lying flat on the table like you see. This was our traditional method of doing it when we found trying to demonstrate to larger groups. It didn't work as well. So one thing we came up with is we started buying these little guitar stands, and they work very well. For holding up the demo board. So it displays a lot nicer in a stand-up situation. More people can see it at once. Now on the circuit side of the demo board, you'll see there's a lot of stuff going on here. First you'll see two main posts. That represents the vehicle's battery, and you'll connect the PowerProbe clips to the positive and negative of that battery. Now this represents a couple of simple circuits. First you'll see it goes from the positive side of the battery to the fuse box. Now those are normal mini ATC fuses in there, typical automotive fuses. We'll come back to that. And then it splits off to two separate circuits. Straight down on the right hand side we have a lighting circuit, so it comes from the fuse through a switch, that's an on-off switch, that's your red switch here, through the lamp to a common ground on the bottom here, that common ground being connected to the negative side of the battery here. So that completes one circuit. Positive side through the fuse block, through the switch, through the lamp, to the ground, back to the battery. That's one circuit. The second circuit is the relay controlled fan circuit. These two components here. So this relay will be controlled by this switch, a ground controlled switch that will, when that relay is activated, allow power to go to the fan and activate the fan. So that one's pretty simple too. We're coming off of battery positive, going to the fuse box, coming out of this fuse here. Power will get connected to 2 points on the relay. This is pin 30, I believe this is pin 85. This is the control. This is the power to the fan. This is the control ground, which will be activated on and off by this switch here, which connects to the common ground, which will come back to the battery. The fan power comes in at this terminal on the relay. When the relay is activated, power will flow through into the fan and then out to ground, back to the battery positive. Two simple circuits, one relay controlled fan circuit, one simple lamp circuit. On the left side, you'll notice these three here. Now, yours may or may not have a real fuel injector here, but there will be a point for showing the fuel injector signal, particularly for the PowerProbe 4. This point will show frequency and duty cycle. These 2 points will show point-to-point resistance, and I believe you can select a couple of different resistances with this toggle switch at the bottom of that resistor schematic there. So like I said, two simple circuits, lamp circuit and relay activated fan circuit. You should have both of those on your board. This power button will turn on these two signal generators here. It'll auto shut off after a while, or you can shut it off by pushing the button again. Now I want to show you something a little bit closer. Let's see if I can zoom in here. Now you'll notice a couple of things about this board. Change the angle here. One, there's these little black and silver points all over the board. All those is access points that you can take voltage or resistance readings, whatever kind of reading you need to do. Those would normally not be there in a vehicle, obviously. They're just there to give you access to readings on this demo board. Number two, you'll notice some of these little toggle switches throughout the circuit here. Now wherever you see one of these toggle switches, I'm going to zoom in really close here. It's a 3-position switch. There's a down position, a middle position, and an upward position. Now you can do 3 things with that switch. Now that'll affect the circuit between point A and point B, like in this one, between these 2 points. Down position, I have low resistance and or normal wiring, pretty much 0 resistance. That's your normal circuit. So low is down, makes sense. If you go all the way high, that will add some resistance to the circuit. And so that'll create a voltage drop when the circuit is under load. And you can also see a resistance reading. In the middle, that represents like a corroded wire or a loose connection or something like that. In the middle you have the option of an open. Now it's like an actual broken wire or connector that's unplugged. So each of these little switches, you're able to introduce bugs in the circuit. Either create opens or high resistance points throughout the circuit, so you can actually create problems that the PowerProbe circuit tester will be able to find. So we've got our board powered up. Let's get our tools set up. We'll put PowerProbe 4 here. And depending on how you set up your display, the cables could be in front, or I like to hide them behind sometimes, but sometimes behind it's not as clear to the customer that this 20-foot cable is actually attached to the tool. But we'll run it back around here. Powered up. PowerProbe 3S. My power. Alright, so we've got the board set up, we've got the tools powered up. This is typically how it's going to look on a display or a presentation. Alright, everything's all set up. Let's see if I can show you a few things that you can showcase on this demo board. Compared to the whiteboard you're able to show different voltages, that kind of stuff. But we're actually showing how it's used in a circuit, and with the bug switches we're able to actually create circuit problems that people can track down. Well, starting with the PowerProbe 3, let's show some of the basic functions. You know, just checking power. Oops, let me turn the speaker on. Checking power. Checking ground. I don't know if you can see the voltage display there. 0, 0, you have a green negative sign. A low tone on power, shown 12.5 volts, a red positive sign, a high tone. So just checking powers and grounds in a circuit, very easy. Checking power, checking ground. Now one advantage of all of our tools is they're connected directly onto the vehicle's battery, so it's always referencing from the battery's negative, which is the best ground on the vehicle, versus any other ground point which might be a bad ground, could throw your measurements all off. Number two, it's always comparing the battery voltage to wherever you're probing in the circuit, the tip voltage. So if it does see a difference in voltage, let's do this one here, of more than half a volt from the battery that it's connected to, no light, no tone. Now I still have a voltage reading. Now I don't know if you can see that, it's 9.2 volts. So no light, no tone. And that alerts you there is voltage drop in the circuit by having no light, no tone. Now the third thing, what all these power probes are famous for, is with these rocker switches you can actually apply battery power or battery ground right out of the tip of the tool. So if there is a situation, for example this one, where I don't have the battery voltage I am supposed to have at this point, well, I can go ahead and rock this switch forward. That'll give me battery positive at the tip, and see how the circuit responds. Sure enough, it got brighter. So that verified I have a circuit problem here. We have some voltage drop, and I only have one wire between here and here, so something's wrong there. We have a corroded wire, loose connection, corroded connection. We'll repair that with our switch, and now we're back to normal. Conversely, on the ground side of the circuit, if there was some voltage loss or some corrosion resistance on the ground side of the circuit, normally you want to see green light 0, 0. You can see up to a half a volt on the ground side and you'll still get that green light. But again, anything more than half a volt, here I've got 3.2 volts on the ground side. No green light, no low tone. But again, with this rocker switch, if I roll it backwards, I'll be able to apply ground at that point and watch how the circuit responds. Sure enough, it got brighter. I bypassed this bad ground and injected a good ground. So we know I had a good ground here, kind of like up above, a bad ground here. So we'll be able to fix the wire in between, and we're back in business again. Another common test taking advantage of the power of these circuit testers is testing from the relay socket. Many components nowadays are controlled right by relays, so going right to the relay socket in the fuse box, you'll be able to test every aspect of that relay controlled circuit. You can check voltages coming in, verify everything's good there. You'll be able to verify your ground control circuit. If I can get on this, that's my switch here. Sorry, I'm making bad contact, but there's my control signal. You can verify the ground path through the component. There it is. And if you apply power at this point, you can verify the component actually works. So you've tested every aspect of that relay controlled circuit, and maybe the last thing you need to test is the relay itself. Each of these tools has a little convenient ground lead. In this case, we'll use it on the relay. Clip it on one side. We'll put the tip on the other side. That indicates I've got continuity through it. I'm going to turn the speaker off so you can hear when I power up the relay. If it's good, it should click. And you hear clicking. So you're able to test every aspect of that relay control circuit, including the relay itself, with this tool. Now these 3 points here, there are some things, and I'll talk about, that you can show on the PowerProbe 3 and the PowerProbe 3S, but they're more geared towards the PowerProbe 4, the more specialized advanced tool. Specifically this one is your fuel injector mode. Your board may have a real live firing fuel injector there. Some do, some don't. But either way, there'll be a test point and a button to turn it on. You'll select fuel injector mode, hit that test point. You'll get the Noid light action up here. You'll get all your fuel injector data on time, ground voltage, supply voltage, inductive kick voltage, all on one screen. And again, you can turn that speaker off if you don't want it. This also turns on this square wave generator. That's supposed to represent like an ABS, crank sensor, that type of signal. We'll select Hertz frequency to kind of demonstrate that one here. You can see that we've got a frequency, we've got positive and negative pulse widths on the bottom here. This bottom one is like a resistance test. There's a switch that can give you different resistances. This is if you want to demonstrate the feed test mode of the PowerProbe 4. Now this is your resistance mode for the PowerProbe 4. If you're just doing component checks like this here, you would use the ground lead for the PowerProbe 4 as your second lead. And read resistance. 13.6 ohms there. Let's see if flip the switch, I think we can get a different ohm reading. If I can hold still. 980, almost 1,000 ohms. So you can demonstrate the resistance reading of the PowerProbe 4. Another unique feature of feed test that you can show on this board is the live resistance testing. Now in a live circuit, you're going to get a red light if you're on the power side of the circuit. You'll get a green light if you're on the ground side of the circuit. But you're able to check resistances in live circuits. This is something unique to this tool that no other tool can do on the market that we know of. So those are the specialized tests here. More geared towards the PowerProbe 4. You can show peak-to-peak mode and audible mode using this test signal here with both of the PowerProbe 3 and 3S. It won't do anything with the injector signal, but I don't believe it'll hurt it. This may indicate path to ground with these two, like a continuity test. With the low resistance, it'll give you a green light. With the high resistance, it will not. So that's the major functions. The point of this board is to illustrate real circuits that you can put in real bug problems that you can trace with these circuit testers and illustrate how easy it is to find those problems using PowerProbe circuit testers. And remember, each of these bug switches will give you either an open that'll disable the circuit, or high resistance it'll cause voltage drop in the circuit. This is a master ground switch. This is a master power switch. This one will cause a positive voltage drop to the lamp. This one to the fan. This one will cause a voltage drop on the ground side of the lamp. And this on the ground control circuit for the relay. And you can stack as many voltage drops up as you want. I can flip all of these switches and really cause a major voltage drop. And I created lots of problems in the circuit, or just a single problem somewhere. You can use it any way you want as far as that goes. And that should do it. Like I said, the point is to show off some, besides just measuring voltages and stuff, being able to show off actually troubleshooting a circuit with these. If you have any questions, again, my name is Dave Barden, technical support at PowerProbe Tech. You can get a hold of me at dbarden, that's D-B-A-R-D-E-N, at pp-tek.com. Thank you.